Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 3 video from the chapter of Heron's formula, I will discuss about how to find the area and perimeter and altitudes of triangles, various types of triangles, and finally how to find the area of a regular hexagon and the total surface area of a regular tetrahedron. This video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me to grow my channel. So subscribe to my channel and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so first of all, let's say we have a triangle, let's say a scalene triangle ABC. So how do we find the area and perimeter of a triangle? The perimeter is very simple. It is the sum of the length of all the sides of the triangle. So perimeter P, uh, So I have a triangle ABC. The length of the side opposite to the vertex A is conventionally denoted by small a. Similarly, the length of the side opposite to the vertex C is denoted by the small letter c, and the length of the side opposite to the vertex B is denoted by the small letter b. So perimeter is clearly A plus B plus C. Now we have the area of the triangle. The basic formula is half into base into height. Now the base can be any of the three sides of the triangle. So for the I have drawn the three triangles. Let's say in the first triangle I am considering the base to be BC. Now what will be the altitude? Altitude is the perpendicular drawn from the opposite vertex, that is A, on the side BC. So let's say this be the altitude. Let's say this is AO. Its height is, let's say, H1. So the length of the altitude on the side BC from the vertex A is H1, or I can say that the corresponding altitude of the triangle, considering BC as the base, is AO or H1. So what will be the area considering BC as the base and AO as the altitude? The area will be half into BC into AO, where AO is H1 is the length of the perpendicular AO on the side BC. Again, consider in the second triangle I am considering AC to be the base. Then the altitude, corresponding altitude, will be the perpendicular drawn from the opposite vertex B on the side AC. Let's say this be the altitude. Let's say this be a BO. So the altitude BO is the corresponding altitude considering AC as the base of the triangle ABC. Let's say the length of the BO is H2. Remember that in general the length of all the length of the altitudes, three altitudes. So since we have three bases, that is three sides, we have three altitudes. The three altitudes will be different in general. Okay, so considering the AC as the base and BO as the altitude, the area of the triangle will be half into AC into BO. Similarly, in the third diagram, let's say we are considering AB as the base, the side AB as the base, then the altitude will be the perpendicular drawn from the opposite vertex C on the side AB. Let's say CO be the altitude, and let's say its height be H3. So area, again considering AB as the base, area of the triangle ABC will be half multiplied by AB multiplied by CO. Now see that since we see that there are three ways of finding the area of the triangle, considering depending on which side we are considering as the base. But since it is the same triangle, the area will be same. So we will have BC multiplied by AO or by 2 should be equal to AC multiplied by BO by 2 is equal to AB multiplied by CO by 2. I can multiply in this inequality, I can multiply all the terms with the 2, and this will imply that BC multiplied by AO, let's say I am denoting AO, the length AO as H1, H1 is equal to AC multiplied by BO is H2 is equal to AB multiplied by H3. Now this is a very important relation, that is the product of the side and its corresponding altitude is equal for all the sides in a triangle, because or you can say that the product of the side of a triangle and its corresponding altitude, they are in inverse variation. So if we know from the chapter of ratio and proportion, if two quantities x and y vary inversely, that is they are in inverse proportion, then we have their product is constant. Xy is a constant. In this case, the constant is the area of the triangle. Since it is the same triangle, the area is constant. So the product of any side and its corresponding altitude will be always a constant, and that constant is equal to the area. From here we can say that from the first equality, that is BC H1 is equal to AC H2, I see that BC by AC is equal to H2 by H1. BC by AC is equal to H2 by H1. Also, I will have AC by AB will be equal to H3 by H2. This is some important concept that you must understand. Okay. Now, there is, so when we know when we know the length of all the sides of a triangle, then there is another formula which is known as Heron's formula. This entire chapter is about Heron's formula, and that Heron's formula, using Heron's formula, we can also find the area of a triangle, where we know where the triangle is not of any special kind, that it is not an isosceles triangle or scalene triangle, or isosceles triangle, it is not an equilateral triangle, or it is not an right angle triangle. Basically it's a scalene triangle. We know the length of all the sides. How do we find its area? So in that case, Heron's formula is Heron's formula for finding the area of a triangle. The area of a triangle in general, conventionally, is denoted by the triangle or delta. This is equal to square root of small s multiplied by small s minus a, where please note that a is the length of the side BC, b is the length of the side AC, and c is the length of the side AB. So small s minus a, small s minus b multiplied by small s minus c. Now what is s? S is known as the semi-perimeter of the triangle. Perimeter is a plus b plus c. This is the perimeter, and semi-perimeter is half of the perimeter. So semi-perimeter is S small s denotes the semi-perimeter, which is p by 2, which is a plus b plus c by 2. So S, from the length of all the three sides, you can find S, and from S you can find the area of the triangle using this formula. So this is Heron's formula. It is very important, will be heavily used to solve various problems. Now let's see what will be the area and perimeter and altitudes of special kind of triangles. Let's say, let's consider an equilateral triangle. Okay. So let's say we have an equilateral triangle where the length of each sides of the triangle is small a. Now, obviously, the Heron's formula can always be used to find the area of a triangle whose length of all the three sides are known. So, for an equilateral triangle, if we know the length of each side, we know the length of all the three sides. So, from the Heron's formula only, I can say smallest, that is semi-perimeter, will be A plus A divided by 2. This is equal to 3A by 2. Now area will be equal to square root of smallest multiplied by smallest minus A, and ABC for all the ABC will be equal to A for an equilateral triangle whose length of each side is small a. S minus A and S minus A. This is equal to square root of this is equal to what is S? S is 3A by 2, and what is S minus A? S minus A is 3A by 2 minus A, which is equal to A. What? Sorry, A by 2. A by 2. S minus A is A by 2. So we have multiplied by A by 2 multiplied by A by 2 multiplied by A by 2. This is equal to square root of 3A to the power 4 divided by 2 to the power 4. This is equal to this will be square root of 3 by 4 A square. So from the Heron's formula, we are getting that the area of an equilateral triangle is square root of 3 by 4 A square. This is super important. You must always remember this formula, that for an equilateral triangle whose length of each side is small a, the area is square root of 3 divided by 4 multiplied by A square. Now what will be the altitude? In an equilateral triangle, all the three altitudes will be same. So let's say, considering BC as the base, 80 is the altitude. So it is perpendicular to BC. Remember that in an equilateral triangle, not actually in an equilateral triangle, in an isosceles triangle, the concept is, in an isosceles triangle, let's say we have an isosceles triangle A, B, C, where let's say AB is equal to AC. Now in this isosceles triangle, if you draw perpendicular from the angle from the vertex containing the equal sides, that is A, on the opposite sides, then let's say 80 is the perpendicular to BC, then 80 will bisect the side BC, that is BT will be equal to TC. Okay. Now so then we know that, okay, so then what will be, we know that the area of this equilateral triangle is square root of 3 by 4 multiplied by A square. Now what will be then the altitude H? Altitude of an equilateral triangle, if you know the area, if you know the side length of each side A, what will be its altitude of an equilateral triangle? So we have BT will be equal to TC will be equal to A by 2, since the perpendicular BT 80 is bisecting the side BC, A by 2. Now consider the right angle triangle ATC. In the right angle triangle ATC, we have, using the Pythagoras theorem, we have AC square is equal to 80 square plus TC square. This implies AC is the length, is the one side of the equilateral triangle, which is A. So A square is equal to 80 is let's say H square. H is the height of the length of the altitude, plus TC is A by 2. A by 2 square. So this implies that A square is equal to H square plus a square uh, by 4. So this implies h square will be equal to a square minus a square by 4, which is 3a square by 4. So this implies the height is equal to square root of 3 by 2a. This formula you must also remember by heart. Area of an equilateral triangle whose length of each side is a is equal to square root of 3 by 4 multiplied by a square, and the altitude of an equilateral triangle of having length of each side as small a is square root of 3 by 2a. These two things you must always remember by heart. Okay. So perimeter is obviously, what is the perimeter? Perimeter of an equilateral triangle is obviously a plus a plus a, which is thrice a. Now small things you must be able to observe. What is the relation between a and perimeter, area and perimeter of an equilateral triangle? So I'm starting from let's say P. Perimeter P is equal to thrice a. How will I get small a in terms of capital A, that is area? From here I will get a will be equal to square root of it will be square root of 4 times a divided by square root of 3, which is equal to twice 2 square root of a divided by actually this is square root of 3. Okay, so P, perimeter is equal to thrice a. This is equal to 3 times a is equal to 2 times square root of a divided by square root of 3. Okay, now this is equal to so 3 is square root of 3 multiplied by square root of 3, and we have multiplied by twice square root of a divided by we have square root of 3. So this is equal to okay. I hope you are familiar with the indices, powers and exponents. Let me try to simplify the square root of 3. So we have basically we have 3 okay, so 3 so this is twice square root of a multiplied by 3 by square root of 3 means 3 to the power 1 by 4. So this is equal to 2 square root of a multiplied by 3 to the power 1 minus, applying the laws of exponents, 1 minus 1 by 4. This is equal to 3 by 4. So this is become a little complicated. Anyway, square root of 3. Square root of 3. Okay, let's not do this. It is becoming unnecessarily complicated. I mean, the concept is that, the idea is that you should be able to find a relation between the area and perimeter of a equilateral triangle. Now, so square root of 3 can be written as square root of 3 multiplied by square root of 3. So this is if you do the product, it will be square root of 3, and we have multiplied by square root of 3 multiplied by 2 square root of a. In the denominator we have square root of 3. This will cancel out, and we have basically we have square root of 3 square root of 3 multiplied by twice square root of a, which is twice square root of 3a square root of 3. This is looking very ugly, but this is, please do not try to remember this formula. I'm just discussing how we can find the relation between the perimeter and the area of an equilateral triangle. The important formula is that the area of an equilateral triangle of whose length of each side is small a is square root of 3 divided by 4 a square, and the altitude of an equilateral triangle, all the three altitudes are same, so altitude of an equilateral triangle is square root of 3 by 2 multiplied by a, and obviously the perimeter is thrice a. Perimeter is thrice a. Okay, let's see the next type of triangle, which is right angled triangle. So let's say ABC is a triangle right angled at B, vertex B. So obviously AC is the hypotenuse and AB and BC are the two arms. Now, so right angle triangle. So obviously the area. So perimeter is trivial. Perimeter will always be the sum of the length of the sides A plus B plus C. Area will be, we can find area will be half. The altitude for this triangle can be considered as, we can consider BC as the base and then AB will be the altitude, or if you consider AB as the base, then BC will be the altitude. So in both the cases, the area will be half into C into A, that is half into the product of the length of the two arms, half CA, that is half into product of the length of the two arms of a right angle triangle. Okay, now if so one altitude is definitely C. So two altitudes are definitely C and A. The length of two altitudes are definitely C and A, because BC is one altitude, AB is one altitude. The third altitude is, if you draw a perpendicular from the vertex B on the hypotenuse AC, let's say BO, let's say this BH. What will be H? So if you are given let's say only if you are given the length of the two arms of a right angle triangle, then obviously we can find the area, we can also find the hypotenuse, and then we can also find the altitude on the hypotenuse. So let's say we have a right angle triangle, let's say PQR is a triangle right angled at Q. Let's say the length of the two arms PQ BX and the length of the other arm QR BY. Obviously then the length of PR will be, using Pythagoras theorem, square root of x square plus y square. Okay, now let's say QO be perpendicular on the hypotenuse PR, and QO, that is H be the length of the perpendicular QO, that is the altitude of this right angle triangle corresponding to the side PR or the hypotenuse. How can we find H? We know X and Y. How do we know? How can we find H? So we know that area will be equal to xy by 2, that is half into height into base, and obviously x and y can be considered either x, you can consider x as the PQ as the base and QR will be height, or if you consider QR as the base, PQ will be height. So in any case, the area of the triangle will be, of this right angle triangle will be xy by 2. Okay, Also, considering PR as the hypotenuse as the base, the area will also be equal to half into the hypotenuse PR, which is square root of x square plus y square and multiplied by h, where h is the altitude corresponding to the base PR, that is the hypotenuse PR. So this implies we are having the relation xy by 2 is equal to h into square root of x square plus y square whole divided by 2. So this implies we can have h is equal to xy divided by square root of x square plus y square. So from the length of the two arms of a right angle triangle, we can find the length of the altitude corresponding to the side corresponding to the hypotenuse as the base. This is one something now I really don't expect you to remember this formula, but in case you are asked to find the length of the altitude considering the hypotenuse as the base, where the length of the two arms are given, you should be able to derive this formula. Okay, now what about if the right angle triangle is isosceles? Now in an isosceles right angle triangle, obviously the two arms are equal. So let's say I have an isosceles right angled triangle. Let's say x, y, z is the right angled isosceles triangle where the two arms are equal. Let's say the length of the two arms is a. So then what will be the area? What will be the, obviously from here we can find the hypotenuse, we can find the area. Also the perimeter. The perimeter in case the perimeter in the second diagram, that is if the length in a right angle triangle, if the length of the two arms are given, what will be the perimeter? So perimeter will be equal to x plus y plus square root of x square plus y square. Okay. In the third case, that is the isosceles right angle triangle, let's say the two arms are of equal length of a. So obviously the hypotenuse, length of the hypotenuse will be square root of a square plus a square, which is equal to square root of 2a. So the length of the hypotenuse will be square root of 2a. Now what will be the area? Area will be obviously a square by 2. Applying the formula, half into base into height, we can consider the two arms, one of the two arms to be the base and the other arm to be the height. So it will be a square by 2 is the area of the isosceles right angle triangle where length of each arm is a. Okay, what will be the perimeter? Perimeter will be a plus square root of 2a. This is twice a plus square root of 2a. If I take so this is, if I take a common, this is a multiplied by 2 plus square root of 2. This is also one interesting result. Not interesting result, but you must be able to find the perimeter of isosceles right angle triangle, isosceles right angle triangle where the length of each arm is given. Okay. Now what will be the altitude? So one altitude, the two altitudes are clearly a because xy and yz are two altitudes and they are of equal length a. What will be the altitude corresponding to the side xy, that is hypotenuse? Let's say this is yo, this is h. So we found that h is equal to xy divided by square root of x square plus y square. So h will be, in this case, x and y are equal, a. So A multiplied by A divided by square root of A square plus A square. This is A square divided by A square root of 2, which is equal to A by square root of 2. So for an isosceles right angle triangle where the length of each arm is A, small a, we are seeing that the area is equal to A square by 2. Again, I am not expecting you to remember this formula, but you must be able to find the area, perimeter and the altitude corresponding to the hypotenuse. So area is A square by 2, perimeter is A multiplied by 2 plus square root of 2, and the altitude corresponding to the base corresponding to hypotenuse as the base is E by square root of 2. Okay, so this was right angled triangle. Now let's see isosceles triangle. So let's say we are given ABC is an isosceles triangle where the side AB is equal to AC and they are of length B, and also the length of the base AC is given, not base, the length of the other side BC is given as small a. So how do we find the area of this triangle? So you can obviously use the Herons, since we know the length of all the sides, you can obviously use the Herons formula to find the area, but but you can alternatively, you can also find the altitude corresponding to the side BC of this triangle. So let's say, as I said, this is an isosceles triangle. If you draw where AB is equal to AC, then if you draw a perpendicular from A on the side BC, then this perpendicular AO will bisect the side BC. So we will have BO is equal to OC. BO will be equal to OC. Okay, let's say the AO, the altitude corresponding to the side BC, B, the length of the altitude AO be H. Okay. So then in the right angle triangle, AOC, using Pythagoras theorem, I have AC square is equal to AO square plus OC square. This implies AC is B. AC is one of the equal side of the isosceles triangle whose length is B. So we have B square is equal to AO. AO is the height of the altitude corresponding to the side BC whose length is A. H square plus OC. OC will be the half of BC, and BC is A. So A by 2 square. So this implies B square minus A square by 4 is equal to H square. So this implies H square is equal to 4B square minus A square by 4. So this implies H is equal to square root of 4B square minus A square divided by 2. So this will be the altitude of the isosceles triangle corresponding to the side BC whose length is small a. So then what will be the area of the triangle? So area will be half altitude multiplied by the base, which is A, which is equal to then we see A by 4 multiplied by 4B square minus A square. This is the area of the isosceles triangle having two equal sides B and the third side of length small a. Now usually I really don't expect to remember this formula. If you can, it is absolutely fine, but you must always be able to derive this formula area based on A and B. Okay. And then obviously what will be the perimeter? Perimeter is nothing but twice A plus B. Okay, so that is all for the isosceles triangle. Uh, let's see. Now, finally, I will discuss about how to find the area of a regular hexagon where the length of each side is a. What will be its area? This is based on basically the area of an equilateral triangle. Now you see this is a regular hexagon. It is having six. Hexagon means a polygon of six sides, and regular means all the sides are of equal length. Now, if you the concept is that one property of any regular polygon, that is polygon regular polygon of any side, any number of sides. This is a regular hexagon that is having six sides. A regular polygon of any number of sides, n sides. If you all the perpendicular bisectors of the sides, perpendicular bisectors of all the sides will intersect at some point, which is known as the center. So this the point where all the perpendicular bisectors of the sides of a regular polygon intersect is known as the center of the regular polygon. So so you can see that, let's say this is the center O. If we draw a perpendicular center O on the side BC, it will bisect the side BC. Also, this will let's say so these are the perpendicular bisectors of the sides of the regular hexagon. And the thing is that since you can see that what will be all these angles. Now, if you now, so we have this point of the center. If you join the centers with all the vertices of the regular hexagon, let's say I join the vertex A with the center. I join vertex B, that is with the center. I join vertex C with the center. I join vertex D with the center. I join vertex E with the center, and I join vertex F with the center. So basically, what is the center? Center is the point of intersection of all the perpendicular bisectors of the sides of a regular polygon. So in this case, this is a regular hexagon. That is, the number of sides is 6. The number of sides is 6. Now, so I have joined the center with all the vertices. So the triangle, you see the triangle AOB. Each side is making a triangle with the center. That is, the side AB is making with the center O is making the triangle AOB. All these triangles will be congruent. That is, all these triangles are equilateral triangle. That is, triangle AOB, triangle BOC. All these are equilateral triangle, and they are congruent. So triangle COD congruent to triangle DOE will be congruent to triangle EOF will be congruent to triangle AOF. So we have 6 equilateral triangles formed by all the sides with the center. You can also see that the entire area of the regular hexagon is formed of these 6 equilateral triangles. 6 equilateral triangles of side length, where each of these equilateral triangles is having a side length of A, which is the length of the side of the regular hexagon. So then the area, we can clearly see that the area of the hexagon A regular hexagon A, B, C, D, E, F will be equal to, since all the equilateral triangles are congruent, their area will be same, and there are six equilateral triangles. That is, the entire area of the regular hexagon is formed of six equilateral triangles. It will be 6 times multiplied by the area of the triangle, each of this triangle, let's say triangle AOB. Now, what is the area of the triangle AOB? It is an equilateral triangle having length of each side small a. So this is 6 multiplied by, we know the area of an equilateral triangle of side length a is square root of 3 divided by 4 multiplied by a square. So this becomes 3 multiplied by square root of 3 by 2 a square. So the area of a regular hexagon having length of each side equal to small a is equal to 3 multiplied by square root of 3 multiplied by a square whole divided by 2. Now again, I really do not expect you to remember this formula. If you can, it is fine, but otherwise from this concept you should be able to find the concept is that the entire regular hexagon is being equally divided by 6 is formed of 6 congruent equilateral triangles, and where each equilateral triangle is having a length of side A, which is the length of side of the regular hexagon. And from there you can easily find out the area of the regular hexagon will be 6 times the area of each of those individual equilateral triangle. And obviously the perimeter of this regular hexagon will be equal to 6 times A. Since there are 6 sides, each of length A, perimeter is 6A. Okay, now the last thing is how to find the surface area of a regular tetrahedron having each edge of length A. Now, what is a regular tetrahedron? A regular tetrahedron is formed of 4 triangular faces, where each triangle is an equilateral triangle. So let's say this is an equilateral triangle. So I'm trying to give a 3D view. So this is an equilateral triangle, let's say. Now we will have another. So this is one of the 4 faces of the regular tetrahedron. There will be three other faces, and all those 3 other faces will be the same equilateral triangle. So let's say it may not look. It will be. I am drawing very approximately. Okay. So let's say this is the regular tetrahedron. So the edges are, so basically how many vertices are there in a regular tetrahedron? There are 1, 2, 3, 4. There are 4 vertices. The base, let's say the base is also an equilateral triangle. Basically all the faces are same or identical equilateral triangles. So let's say A, B, C, A, B, C, D be the regular tetrahedron. So what are the faces? The faces are the triangle BCD, and all these are equilateral triangle BCD, triangle ABC, triangle ABD, triangle ACD. These are the 4 faces of a regular tetrahedron, where all these triangles are equilateral triangle and their length of each side is same. Now, what are the edges? How many edges are there in this regular tetrahedron? The edges means a side which is common to 2 faces. So one edge is AB. The edges are AB, AB, AC, AB, AC, AD, BC, BD, BD, and then also CD. These are the edges and they are of equal length, which is basically the length of each of the equilateral triangles. So we say the regular tetrahedron having each edge of length A. So all these edges are of length A, which means that A is the length of each side of all these equilateral triangles. That is, each equilateral triangle is one face of the regular tetrahedron and there are four faces. So these are all A, 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 and A. So then what will be the area of this regular tetrahedron? So area of this regular tetrahedron, let's say A, B, C, D will be equal to not area, sorry, I'm really sorry, the total surface area. The total surface area, since there are four faces, the total surface area of this regular tetrahedron is nothing but the area of all the faces, and there are four faces. So total surface area. Now you might have already learned in your previous class, or maybe also definitely in this class, surface area and volumes of solids. So surface area, which is conventionally denoted by the letter capital S. Total surface area will be equal to 4 times the area of each of the faces, and each of the faces is nothing but an equilateral triangle having length of having side length of A, where A is basically also the length of each edge of the regular tetrahedron. So let's say area of triangle BCD. This is 4 times multiplied by the area of each of the faces, which are equilateral triangle having length of side A is nothing but square root of 3 divided by 4 A square. This is equal to square root of 3 multiplied by A square. So for a regular tetrahedron having each edge of length A, which basically means the length of each edge is nothing but the length of each side of all the equilateral triangles. There are 4 equilateral triangles, one equilateral triangle for one face. So the total surface area will be square root of 3 multiplied by A square. This thing you should remember, that in a regular tetrahedron where the length of each edge is A, then the total surface area is square root of 3 multiplied by A square. So based on these concepts discussed in this video, I will try to solve a few problems in the next video. So please stay tuned. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel. Do not forget to press the bell icon so that you will be notified by my future videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.